I will explain recursion in this video, I promise. But first, I want us to solve a little problem. So let's say we have an array of numbers, just from 1 to 5, and we have to write a function to sum the numbers in an array. So the input to this function will be an array of numbers, and we have to return the total sum of that, and in this case, the result should be 15. So a very simple solution to this would be to create a total variable that is set to 0, loop through every item in the array. Since they're all numbers, we're just going to add each item to the total. So the first time 1 will get added, then 2, then 3, and so on. And then we can return the total at the end of this function. So if I call some numbers with this array and get the result here, I should be able to console log the result. And what we want to see is 15 printed out to the console. So let's run this. And we see the result is 15. So that is a really basic problem with a really simple solution there. And if you need to, you can pause the video, make sure this makes sense to you before we move on. Because I want to make this a little bit more difficult. So I'm going to say this is array 1. This was the first array. This is the simple example. We loop over the numbers, we add it to a total. But let's say we now get a more complex array. I'm going to call this array 2. And this array, like the first one, can contain numbers, or it can contain arrays of numbers. So in this case, the array contains the number 1, then it contains the array with numbers 2 and 3, then 4, then maybe an array with the number 5. So it still has the same numbers, and I potentially want the same result from this function, but instead of just containing numbers, it now has numbers or arrays of numbers. So if I run this code as is, it's probably not going to work because this was only set up to work with numbers. But let's just see what happens. And let's actually name this correctly so it works. And the result is 12,345, and that is not correct. That is just JavaScript trying to add everything together and converting things to strings to make it work. So what I need to do is figure out how to make this actually work. And let's just go step by step here. So first, what I'm going to do is console log each item so we can get a better idea of what's going on within this loop. So if I do this again, we'll see that the first time we go through the loop, we have the number 1. That makes sense because 1 was the first item in the array. The second time we go over the loop and console log the item out, we get the array 2 and 3. So when we have a number, we can add that to the total. But when we have an array of numbers, we have to do something different. Then we get a number, and then we get an array of numbers again. So these are the cases, these arrays of numbers, that I want to handle a little bit differently. So if I'm in this for loop and I come across an item that isn't a number, it's an array. So I'm just going to make a little check here. If array.isArray, this is a way of checking if something is an array or not. So if I've come across an array of numbers, do something. But if it's not, then it's going to be a number, and we just add that into here. So if we read that a little bit differently, if it's a number, add that number to the total. But if it's an array of numbers, do something else. I'm not sure. So right now this should work, but we'll get the wrong value. It'll be 5 because it's only adding the 2 numbers. But when we have an array of numbers, what do? How do I get those numbers as part of the total? How do I add those numbers to the total? So we've already solved this problem by using this for loop here. So what I could do is the same thing again. I could just add another for loop. So let's go const, item 2 of item, because item is an array of numbers. So I'm just grabbing the numbers out of this array now, just like I did before, but with another for loop. And I'm going to add this to the sum, or no, the total. Yeah, total plus equals item 2. There we go. So just by adding another for loop, if it's an array, loop over that array, add the numbers in. I think this should work. The result here should be 15. Yeah, there we go. So this now works, this function, whether it's an array of numbers or it's an array that contains numbers or arrays of numbers. So this is really great, made it work for multiple cases here. Now let's make it a little bit more complex. Array 3. What if my array can contain numbers or arrays of numbers or arrays of numbers or just unbounded arrays of numbers? There we go. So again, the array still contains the same numbers. I still want 15 out of this. But now there's this unlimited bound on how many arrays there are, how deep into the array structure a number could be. So if I keep going with this process I've got up here, I'll basically just keep writing these if statements and for loops forever, just to try and meet every single case that I might come across. So that's not ideal, that kind of sucks, and this code is going to get out of hand really quickly. So I want to go back a little bit to before I had this complex array, actually all the way back to before I wrote the for loop. Okay, right here. Here's where I want to go back to, because when I was observing this, I said, if it's an array, if we have one of these inner arrays that contains numbers, we just need to add those numbers to the total. We need to do the logic that already exists in this function. So I copied that logic and pasted it into the if statement, and that worked. But instead of copying this code and duplicating it multiple times, what I need to do if I come across an array of numbers is to sum the numbers in the array. And I already have that logic. All I need to do is call the function that runs that logic. So if I come across an array, I'm going to pass that into a function that deals with arrays and loops over the numbers in that array and adds it to the total. So I'm going to let that sink in for a moment, because what we're doing is calling this function from within this function to try and reuse the logic that already exists there. And because some numbers returns a value, I am going to need to add that to the total here. And before explaining anything else, let's just make sure this works. We're expecting to get the number 15 out of here. So node recursion, we get 15. So this works for that for loop where I have an array of numbers or an array of numbers. But because every single time this function gets called, we check if there's an array. And then if there is an array, we call the sum numbers function again. No matter how many arrays there are, no matter how deeply nested the arrays are, if at any point we come across an array within a child array or a child of a child array, whatever, it will still be able to function. So if I duplicate this again as I did before, we're going to have that array 3 again. And I just create arbitrarily deep nested arrays, just everything's in an array of arrays. This should still work the same way. And we can verify this works. I'm just going to run this code, and again, we get 15. So no matter how many arrays I have in here, this is always going to work now. And let's break this down. Let's see how this is actually working. So if we go back to the first array here, and we call this sum numbers with an array of numbers, this for loop is going to get executed for each of the numbers in that array. And we're going to check if the item in the array is an array, and every single time that we loop over, it's going to be a number. So it's never going to call itself from within this function as long as we pass in just numbers. It's just going to keep hitting this case here and keep adding those numbers to the total. Now, if we look at the second array, we pass array 2 into some numbers. The first time the for loop executes, we're going to have the number 1, and it's going to add that number into the total that we've created. Then the second time the for loop executes, it's going to find that second array with the 2 and the 3 in it. And when it finds that array, it's going to call some numbers again with 2 and 3 in it. So we pass that array into some numbers. Some numbers will loop over the numbers 2 and 3, add both of those numbers to the total value out of this version of the function that is called. So once that's done, we're done with that function, we get the return value, which is 5, and then we add that to the total that we're currently calculating for the entire array. And then it goes to the next item in the array, in the outer array, which is 4. And because that's a number, we just add it to the total. Then we come across to the last item in the array, which is an array that contains 5. Since it's an array, we call some numbers with that array. Again, we're invoking a new version of the function. That version of the function loops over that array, which contains one item, adds it to the total, returns that total out of that function. We get that return value, add it to the total, and then we're done. We have the total value of all the numbers in the array. And this works the same way for any array we have. It works the same way for array 3. Array 3 is just a little bit more complex. Some numbers will be called much more when we pass in this kind of array, but each time the outcome is essentially the same. And we achieve this logic, this quite simple logic really, by using recursion, by calling a function within itself. And there's something that I want you to notice here that I'll bring up again later. And that's, if we look at the array, we can see that this outer array is the main problem. It's the main thing we're trying to solve. And every array within this array is just a smaller version of that main problem. So we have an array that contains arrays or arrays of numbers, and we look at one of the arrays in here, and that is the same definition, it's just a smaller version of it. And again, this is the same thing, just a smaller version of it. Same thing, just a smaller version of it. So when you notice you have a problem that can be broken down into smaller versions of the same problem, that is a hint that recursion might be a good solution to the problem, because we're just going to use the same code, the same function, to try solving that problem over smaller and smaller versions of that problem. So I'm going to comment all of this out for now, and let's talk about what recursion actually is. But first, make sure you're subscribed to this channel and hit the bell icon so you don't miss any future videos, and consider joining the channel membership so you can support me in making more videos like this one. So if we have to write a function that will log a number up until a certain number, so for example, if I put in 10 here, it would log from 1 to 10. If I put 100, it would log from 1 to 100. This would be a pretty easy function to implement using a for loop. I could just say for let I equal 1, I is less than or equal to num, I plus plus, and then I'm going to console log num. And then down here, I'm going to log number 2, and I'll put in 10. So what I'm expecting to see printed out to the console is just 1 to 10. So let's see. No, I messed up. I didn't mean to console log num. I meant to console log I. So let's try that again. And there we go. 1 to 10 is now printed out to the console. So this is a fairly small problem again. I'm just looping 10 times to try and print out numbers to the console. Now, if we had to do this, but we weren't allowed to use a for loop and we weren't allowed to use a while loop, how would we implement this function? So I'm going to copy this, remove the contents, and comment out the first version. Well, if we don't have loops, if we don't have iteration, one way of doing this is to use recursion. Here I got the function log number 2, I'm going to pass in 10. So the first thing I want this to do is console log 1. Then I want to be able to call this function again and have it console log 2, and it just keep going up until it hits 10. So what I can do here is have another variable, I'll call it I, just to be consistent with the previous version. I'm going to set the default value to 1. And what I'm going to do is console log I, and then I'm going to call log number 2 again, pass in the number that we're logging to, and then I'll just pass in the next value here, so I plus 1. So if we think about how this would run, the first time it would console log 1, then the second time we call this function, we're passing in 1 plus 1, which would be 2, so it will console log 2. Then the third time we call this function, we'll pass in 2 plus 1, which would be 3, and it will just keep going up. We'll keep incrementing the value every time we call this function, which will keep logging out the different values. So let's see what happens if we run this, and we get a maximum call stack size exceeded. And this is what happens when you have unbounded recursion, because a recursive function is a function that calls itself, but at some point doesn't. So we need a base case. A base case is the case in the algorithm where the function stops calling itself. So in this case, the base case is when I reaches number. In this case, it'll be 10. So what I want to say is if I is less than or equal to num, then we'll console log I, and we'll call the function again. This is the recursive case. This is when we want it to keep calling itself. But as soon as I is bigger than num, we stop, we do nothing, we return out of the function. So we're just done at that point. So now this should work in the same way as the for loop one did, where we just get 1 to 10 logged out to the console. And if we look again, we can see the logic is pretty similar. We have the for loop, we have I equal to 1. I'm checking to see if I is less than num. We are adding 1 to I every single time. It's just, this is using iteration, something built into JavaScript. And this is using recursion, where we're just calling a function over and over again to do things multiple times. So recursion is an alternative to using a for loop or a while loop. It's an alternative to iteration. Anytime you could use a for loop, you could use recursion, and anytime you can use recursion, you could use a for loop. But some problems, like 5% of problems, maybe less, are really good and really easy to implement when we use recursion, and really difficult when we use a for loop or a while loop. And the example I showed you earlier, this one, this turned out to be a really easy problem to solve with recursion, but when we thought about it using for loops or while loops, it turned out to be a little bit more complex. For the most part, you will just want to solve your problems using a for loop. You won't want to use recursion, but there'll be some times where a problem is just so well fitted for recursion that it would be insane to not use recursion. And most of the time that happens with recursive data structures like graphs. And this array down here, array of arrays, is just a simple graph. And to make the definition a little bit more complete here, recursion is really when a function or set of functions calls each other. So if I had a function A that called B, and I had a function B that called A, this would still be recursion because the functions are calling each other. A function doesn't have to call itself, it just has to eventually come back round. So this would still be recursion, but you must always have that base case. You must have some condition where if this happens, we return out of the function and we don't actually do the recursive case. At some point in the algorithm, you must stop calling the functions. And now I want to look at a little bit more of a practical example in web dev. And I have a basic web page here. I'm just going to expect the elements, and we'll see that it's just a bunch of divs. So I have this page, there's a body. The body contains two divs, and I've given them IDs. And each div can contain more divs, and those divs can contain more divs, and this div can contain more divs. So it's just a bunch of divs, but it's a nice demonstration of a tree. So the body is an HTML element, it's a node, and that can contain children, these two divs, and these divs can contain their own divs, and those divs can contain their own divs, and it can just be this unbounded chain of children. And if I move over to the console now, I'll be able to access the document.body directly like that. So I can access that body element that then has those children, and we can start playing with the DOM objects in JavaScript. Now, we know that we have access to things like query selector and get element by ID and get element by class name, but I want you to imagine for a moment that you have this DOM structure. You have all of these elements, and you have to try traversing the DOM to find, let's say, the div with the ID E. How would you manually write the code that traverses the entire HTML page just to find a single div with a specific ID? So if we take a look again at the document.body, this is the element. It has an ID, so we could check to see if this ID was E, triple equals there. So on an element, I can check to see if an ID is the one I want, but if it's not on the body, then I need to go to the body's children, and if it's not on those, I need to go to their children. So each element in the DOM, including the body, has a children property, and this is an HTML collection. And it kind of looks, in this case, like it has 4 elements, but really it's just got 2. It's just duplicated for display here. Because although an HTML collection is kind of like an array, it's not an array, but there are just 2 elements in this, and we can see that again in this structure here. The body contains div A and div G. So back in JavaScript land, I can see that document.body.children is a collection where I have A and G, div A and div G. So what I would need to do is check if each of these children, each of these 2 divs, has the ID that I'm looking for. And if they don't, then I need to go to their children. So just to take a quick look at this, I could just select the first child in that collection, which is div A. And then I would need to go to div A's children, which I can see is an HTML collection that just contains a single div, div B. So I could go to that child, see if that has the ID I'm looking for. If it doesn't, go to all of its children. This has 3 children. And basically what you're doing is you're just going down this tree structure to try and find the div that I'm looking for. So let's take a look at the HTML file. And here it is. Here's my tree structure, the body with all the divs. And I got this little script tag up here. And what I want to do is create a function called get element by ID that accepts an ID and returns the element on the page that contains that ID. So if we're looking for the div with IDE, it should return that DOM node. So what we're going to do is pass in an ID, but also pass in the node, the parent node that we're looking through. So by default, we're going to start at the document.body. And I'll do that simple check on the node. So if the document.body, if the node in this case, has the ID, let's see if the node.id has that ID, then we're done. Return that node. So if I was looking for a node with an ID and the document.body had that ID, we'd be done. Find that ID. This is the base case when we just like break out of this function. But if the current node doesn't have that ID, then I need to loop over all of the children. And I need to do the exact same logic. So go to all of the children of the body, which in this case is div A and div G, and check if they have the ID. And if they don't, then check all of their children, and so on until we find the element with the ID. Or worst case scenario, there is no element with that ID and we just search everything and return nothing. So what I'm going to do here, because I need to check the ID of that child and all the children of that children, I'm just going to call this function that's already doing that. Get element by ID. I'm looking for this ID, whatever ID is passed in, and now the root node that I'm looking from is the child. So the first time this function gets called, it'll be with document.body. Then we'll go to the first child of document.body, which is A, and we'll call this function again with div A. It'll check if it has the right ID. If it doesn't, it will go to the first child of A, which is B, and it will just keep going down this path until it tries to find one of those elements. And this function should return a node if it finds something. So I'll just say found. So if we found anything in the children, this will have a value. So if found has a value, then we can return found here. And this is all we need to traverse the entire DOM to see if an element has an ID. And I can test this out right now. I'm going to call get element by ID, pass in E, and then console log that element out. So I'm going to refresh this page. Document.body is not iterable. No, it's document.body.children. I don't want document.body. I messed up. It should be node.children. There we go. Okay. So the first time that we call this function, node will be document.body. The second time we call it, it will be a div. And the third time, this could just be any node within the DOM. We're always going to be checking its children to see if its children have that ID. So let's refresh again, and there we go. So I found the element with IDE, and console logged it out, and that just worked, and I can now see that div there. And this recursive algorithm is called depth first search, because we're starting with a node and checking to see if that node matches the criteria of our search. And if it doesn't, we're then going to its children, and the child now becomes the root node that we're searching through. So we start with document.body, then we go to div A. If div A isn't the one we're looking for, then we go to its children, and we just keep traversing down like this. And if we get to the end, if we get to a leaf node, then we just start coming back up the stack, and we go down as far as we can go, and then back up, and then down as far as we can go again. And we're basically doing a walk around the outside of the tree here to try and find the node that we're looking for. And this is a really simple problem to solve using recursion, but if you were to try and solve this using iteration, it would be just a little bit more difficult. It wouldn't be as nice a tool for the job. And if all of this seems confusing and difficult, that's not uncommon, because recursive data structures and recursion are a little bit more difficult to wrap your head around than just your standard flat data structures like arrays and standard for loops. Those are much simpler to think about, much simpler to reason about. But once you start dealing with these recursive data structures, recursion really lends itself well to almost any problem that you'll have.